Start recording. Okay. So now types of routes, right? So we have been talking, about L2 EVPN and L3 EVPN, and we have discussed, how we will advertise the MAC, right? MAC information, ARP information, and all that stuff. We want to advertise this MAC, right? Which is learned locally here, right? Locally, this MAC we learned here, and we want to advertise using EVPN, using MPBGP, right? And similarly, ARP, whatever locally ARP we have learned, we want to advertise that, correct? Or in case of flood list, right? Flood list also we want to advertise, right? So there are many information which, and in case of L3 VPN, we want to advertise the IP prefixes, right? So we have discussed that, through EVPN we will advertise MAC, ARP, all this information, but we have not discussed how, right? We what basically format we will use, or what will be the BGP MPBGP packet looks like, right? So that's where this different types come into place, right? So these are different EVPN route types. So we have different route types, type 1 to type 5. There are even 6, 7, 8 as well. So I think type 7 is for multicast EVPN, right? So that there are others as well, advanced. But what we will discuss in this is type 1 to 5, right? Which is basic for EVPN. And in that also, we will talk about more on type 2, type 3, and type 5. Okay. So type 2 is nothing but to advertise MAC and ARP information, right? For L2 EVPN. So in L2 EVPN, we want to advertise MAC and ARP information. So for that, we will use type 2 route, right? Type 2 format. Type 3 inclusive multicast route is for flood list, populating the flood list, right? So this is again L2 EVPN, right? This is also for L2 EVPN. So type 2 and type 3 is used for L2 EVPN, right? L2 EVPN. Type 5, we will advertise IP prefixes, right? IP prefixes 10.10.00.24, right? /24. So this is L3 EVPN type 5. So this is the three main which we will go in more depth, right? Type 2, type 3 for L2 EVPN, and type 5 for L3 EVPN IP prefixes. Now type 1 and type 4 is for multi-homing. Multi-homing means we'll just see what is multi-homing in next slide. So that is for, that will not be used. We will not use type 1 and 4 for MLAG pair and VTAP MLAG. Where we have MLAG, we will not use type 1 and 4, but we will use that in case of multi-homing. That we'll discuss what is multi-homing, right? So in that case only we need to use type 1 and 4, and that is generally with MPLS, right? With VXLAN, generally we will have MLAG because we will have Arista devices and we can form MLAG, so we don't need to have type 1 and 4, right? So most of the cases of VXLAN EVPN, what you will see, that will have type 2, type 3 for L2 EVPN and type 5 for L3 EVPN. Okay. Type 1 and 4, you will not see much used in VXLAN EVPN. It will be mostly used in MPLS, right? But not with VXLAN. But still we will discuss basic understanding of 1 and 4. Okay. So any question before we further proceed? So these are different types. Okay. Now format, right? So how we will advertise this route, right? So this is the format. This is general format, right? This will be part of every route types. So basically it starts with MP reachability NLRI, right? With and flags. So let me again, let's see the same here in packet capture as well, right? So that we are okay. So this is BGP update message, border gateway protocol update message, right? Path attributes, correct? Origin IGP, this is also part same as our normal BGP AS path attribute, right? and this MP reachability NLRI. So this is what we are looking for, right? This is for our different type of route advertisement, right? So let's go one by one. So first is MP reachability NLRI, right? And then flags. So this is MP reachability NLRI, different flags, right? Optional, non-transitive, right? Then type, what type, right? MP reachability NLRI, type code. So this is MP reachability NLRI type code 14, then length and AFI and SAFI, right? So this is common for all type 5, for 1 to 5 updates, right? This is common header. Flags, MP reachability type, length, AFI, SAFI, and next hop address, VTAP IP address, next hop address, which is this 1111. What does that mean? This VTAP, right? This whatever information or route information we are sending, that is originated by this VTAP, right? And that will be sent to another VTAP. So another VTAP will know that this MAC or route, we have to advertise it to basically it's behind this VTAP 1111. Next stop is this VTAP 1111, right? Is it clear? Any question so far? So this is general, general basically header. Okay. After that, we will have route type, right? Which type of route type out of 1 to 5, which one we want to advertise in this update, right? Reachability NLRI. So that's this one. So yeah. So this, right? Now further, if we go inside NLRI, reachability NLRI, MAC advertisement route, right? Route type 2, right? We want to advertise type 2 route. That is either MAC and ARP information, right? So that is route type, route length, and route type specific field. So route type and route length. So this is route type and this is the length of this route, right? So this is the, so one is common header. After that, which type of route we want to advertise. So MAC advertisement route, which is nothing but type 2, right? And then length of it. And then route type specific field means now for each type, right? Different type, we have specific field for that, right? Detail, more detail about that route information, right? So that will follow. So this is how is the format of how we will send the reachability or basically routing information, right? The way we send BGP information, routing information, this is how we will send MP reachability information, right? It can be MAC, ARP, flood list, or IP prefix, right? Any question if you have not understood this much? Okay, so then let's move to next slide. Okay, so yeah, this is again the same, right? What I showed you in this basically in packet capture. So these are the different fields: path attribute, AS path, MP reachability NLRI, and then flags, right? And then MP reachability NLRI length, and then AFI, SAFI, and next hop address, right? VTAP address. So this is the format, which is nothing but this format, right? Up to this, it was up to this. And then it is followed by route type, type 2, type 3 route, and length of that route, and then individual route types, header information. Okay. So let's move. Okay. So now what is multi-homing, right? So we have, I told you about multi-homing. So let's discuss what is multi-homing. So
Vishal,
yeah,
just
yeah.
sorry for interrupting.
No problem. No problem.
I just want to go in the previous slide. You showed this is a BGP update message, and for every type 2, such as a MAC getting advertised or learned in the VTAP, will it generate update message every time it is learning?
Yes. So as soon as you learn the MAC, new MAC address, right, it will generate this update message. Same as BGP, normal BGP. As soon as you learn particular route, right, you will generate that route. And when that route is no longer with you, you will generate unknown, basically withdraw,
Withdraw.
right?
Okay.
Withdraw MP unreachability NLRI, right?
Okay.
So same way here also, as soon as you learn the MAC on local VTAP, right, you will generate the MAC advertisement. And same for R.
Okay.
Okay. Okay. Any other question?
That's it.
Okay. Okay. Perfect. Okay. So multi-homing, right? What is multi-homing? Let's say this is the scenario, right? You have two devices. You have two device, but this is not Arista. One is Arista and one is another vendor. Can you configure MLAG between these two? No, right? Another vendor might not support that, or you don't have compatibility to configure MLAG. Now you have this device, right? Switch, host, right? Multi, which is connected to both the device in MLAG. Let's say in MLAG, right? And both links are active. Let's say, right? Will this link come up? Port channel will come up. If you don't have MLAG, will this port channel come up?
No.
No, right?
No.
So that is one issue, right? Port channel will not come up, correct? Right. Another issue. What is the another issue? Can anyone tell me with this? Let's say we may configure static port channel, right? What is the another issue? Just consider this as active, like this, okay? Maybe we can just refer this one, active. What is another issue?
The primary, secondary.
Okay, 1 minute. Let 1 minute. Let's don't confuse with primary, secondary. Let's take this. Okay, this one. Both are active. Okay, port channel. This one, but there is no MLAG. Okay, so one is port channel. LACP basically will not come up. We can configure static, right? What is another challenge with this? With this.
So as both of the VTAPs will advertise their host.
Mm-hmm.
Once they learn of the host, they will send out a route, which so both of them will send individual routes, right?
No, so this is L2 link. So gateway for this is host. Okay, this is host, and the
Okay.
gateway for host is this VTAPs. Virtual IP is at VTAP. Okay.
Okay.
So this is the gateway to VTAPs. See, one another issue is ARP request, right? If let's say you want to know the ARP for this host, this guy has sent ARP request, but reply might go here, right?
Oh yeah, yeah.
And with MLAG, we used to, and VXLAN agent, we used to sync this ARP request reply, right? But in this case, you don't have anything, correct? You can also maxing. So in when let's say this guy sends some packet, you learn MAC locally, and MLAG will sync that MAC address to this guy, right? And then it will update that, hey, this port channel 100 has this MAC, right? Port channel 100 has this MAC A learn, right? A learn.
Yeah.
But now without MLAG, that is also a problem, right? One more thing, let's say this is another VTAP here, right? It is sending ARP request and host here, right? Now this host wants to communicate to this host, right? This host, it sends out ARP request, right? And it will flood to all the VTAP. So it will come on this VTAP as well, on this VTAP also, right? Because they are not in MLAG, both are different VTAP. Now both will decapsulate the packet ARP request and flood it here and also here, right? So basically this host unnecessarily will get two different copies of ARP request, right? Otherwise, if it is MLAG, only one guy will send out, right? Have you got this?
Yeah.
Right. So basically, these are the different problems which we solve using, this one MLAG. But now it's not possible because we don't have MLAG, right, between these two devices. So this is called multi-homing, right? Multi-homing means basically you have two different vendors, or basically you don't have MLAG two different devices, but it's still, your host is still connected with both of them, right? Multi-home, host is multi-home. Right now it can be different ways. One, it can be either host can be active and standby, right? So this link is always active and this is standby, and as soon as this link goes down, this will become active. So the host can be configured as active standby, right? And then there is not much problem, because all the traffic will come here and ARP also requests go here and come back here, right? So if this is the way you customer has configured active standby, then that's not a big problem, right? It will work fine. But obviously you won't be able to utilize both the links because it's active standby, right? But there are implementation where they want to configure it as active, right? And in this case, because you don't have AMLAG in between, you won't be able to, sync MAC addresses learn locally. ARP address also, ARP request might go from here and reply might end up here, right? Or you might end up duplicate packets, flooding bump traffic to the host, right? Because both will send. So these are different issues, right? With multi-home, correct? When you don't have AMLAG. In fact, there is one more scenario where you have three links. So one host is connected to three different devices, right? Three different devices. So this is on all active. So this is also one part of AMLAG, multi-home. In fact, it can have even 4 also or 5 also, multiple, right, connections. So this is also possible, right? And this is also called multi-homing, right? But obviously all that issues what we discuss here will also be present here, right? Because our request might go to any other device. We will keep flood bump traffic on from all the links, right? Multiple copies will be received by this guy. MAC will not be synced, right? So these are different issues we will see with multi-homing, right? Because AMLAG is not there. But one advantage of it is you can use different vendors, right? No dependency on same vendor or AMLAG dependency, right? Feature should not be supported. And you can have more than two. In AMLAG, you can have only 2 devices, right? AMLAG. But now you can have multiple devices, multi-home, right? This host can be connected to multiple VTAPs, right? So that is also one advantage of this multi-home. Okay. Generally in VXLAN EVPN in data center, right? We see that generally customer use same Arista, right? And they have AMLAG between these two VTAPs, right? So generally we don't see this multi-home with VXLAN, right? EVPN or VXLAN. But when it comes to service provider, right? It is very much possible because it is, say, let's say this is our Arista, right? Arista company router, and we have taken connection from service provider, then obviously it will have different connected to different device, and this two device might be not in MLAG, right? So in this case, multi-homing comes into place in case of service provider and MPLS, right? But for VXLAN, generally we will not see, because in data center they use same Arista devices and create leaf spine and MLAG pair. Okay. Any question? Okay. So now when we have this multi-homing and we discuss different problems, right? MAC sync will not be there. ARP might go, ARP reply. Basically, ARP sync is not there, right? Which we have in MLAG and VXLAN. And also third is multiple duplicate copies, right? Will go to the host, flooding of traffic, right? So to address all these issues, right, we have type 1 and 4, right? So we have type 1 to 5 routes, right? EVPN route types. 2 and 3 is for L2 EVPN, 2 is for MAC and ARP, 3 is for floodless population, 5 is for IP prefix L3 EVPN, and 1 and 4 is for this multi-homing devices, this type of scenario. we are going to use to address all these issues which we observed because there is no AMLAC, right? So that will be resolved by using this type 1 and type 4 route types. So by using this, you can use any, so basically using EVPN, which is advantage compared to HER or CVX, which will not provide you this, right? That you can use this type of multi-homing, right? By using EVPN. So that is one more advantage, right? We will see when we discuss type 1 and 4, right? How we will address these issues. Okay. Okay. So yeah, any question?
Hey, Vishal. You go first, Roger.
Sorry. Yeah, go ahead. Go ahead.
Vishal, so EVPN multi-homing involves BGP in all the devices to be enabled, right? So
yes. Basically, yeah, you have to for EVPN. As soon as EVPN comes, right, you need to you need to have MP BGP running or supported on all this VTAPs to advertise.
How about the endpoint?
Host need not have. This is host. This does not host or L2 switch, and behind that host that need not have to run EVPN. This will just, this is all L2. Behind this is all L2, right? So your gateway is here. For host, gateway will be here, right? So here you need to run MPBGP. So as soon as you learn ARP, MAC, or type 1 and type 4 route for MPBGP, you need to run BGP EVPN here on VTAPs.
Does it involve a LACP between the host and the two EVIs?
Yes, this LACP we will run, but because LACP with this, right, it will not come up because there will be two different system ID, right? It might not come up. So for that, we have provision in type 1 and 4 or configuration so that this LACP comes up.
Okay, from an host point of view, it is a normal LACP port channel.
Yes, for host perspective, it will receive same LA system ID from both. And for, so basically as for host perspective, it's single switch.
Okay.
Yeah, because we will send same system ID, LACP system ID to the host so that we can bring up port channel using LACP.
Okay, so any data center devices can be utilized just like normal.
Yes. Any vendor, basically. Obviously, they should support EVPN, right? So that is preliminary, but they might not support MLAG, right? If it is a different device, it will not support. They are not compatible with each other.
Okay. Thanks.
Yeah.
Hey, Vishal, I have one question, if it's okay.
Yeah, please go ahead.
I joined a bit late, so I'm not sure if you covered this or because you guys mentioned something about that there would be ARP issues if you don't have the MLAG, right?
Yes.
And there's something that we do like an ARP sync, and it's like a BGP update that happens between the two VTAPs.
Okay, so you are asking, so you agree with ARP sync, right? There will be issue with ARP sync, right? Because there is no ARP sync, which we have in MLAG, correct?
Yes, yeah. I'm thinking if we're not using MLAG, we probably need to use the IP address virtual with the ARP sync feature.
Yeah, but here again, even you use IP address virtual with ARP sync feature, right? But you don't have MLAG to inform each other, right? Share that information to each other, right? See, even IP address virtual also uses this peer link to share that information, right? That, hey, to sync the ARP detail, right? So when this ARP is learned here, right? Let's talk about MLAG. Okay, let's clear this. Okay, so let's talk about this is MLAG. Okay, now this guy has sent ARP request, right? The reply might end up here, right? We have VXLAN configured, right? And IP address virtual configure, right? So that VXLAN agent will take care of ARP sync, right? Because ARP reply comes here, and this guy will eat up, consume that ARP and update its ARP table, right? Now what it has to do is it has to sync ARP with the neighbor peer device, right? Now through which link? So basically it will send some message to the peer device that, hey, this is the ARP you should update, ARP sync message, right? And that it will send using this peer link. Okay. L2 peer link, right? But now this L2 link will not be there in case of MLAG, basically multi-home, right? What we are discussing, there is no link. And above is L3 links. These are all L3 links, spine, for to connect it to the spine. Okay. So basically, so first of all, see, this ARP sync feature will only work if you have MLAG, right? It will only sync with MLAG peer, but here there is no MLAG peer. That is one. Another, even though you make it that let's sync it, you don't have any link, L2 link to sync that, right? ARP. It will ARP, right? So basically you don't have connection between these two to sync this ARP.
Yeah. Yes.
Okay. Yeah. So basically, that's why how we will achieve this, right? Obviously, we want to sync this ARP information or whatever MAC to this guy, right? This guy should know. So that's what we are going to achieve by using type 1 and type 4 route types. And we'll see how.
Okay. Okay. Thanks.
Yeah. Any other question?
Actually, I asked it because I have a case on this now. Yeah.
Okay.
Sorry if there is anyone else that has
fine.
a question.
Yeah. Okay, perfect. I think then let's move ahead. Right. Okay, so now we will, discuss type 1, type 2, type 3, 4, and 5, right, one by one. Before we go and discuss type 1, let's discuss type 2, because type 1 will be depending. There are few information or things which also depends on type 2. So let's first go to type 2 and then we'll come back to type 1 and other, right? So type 2. Type 2 is nothing but advertisement of, it is for L2 EVPN, right? L2 EVPN. What information we will advertise? MAC address, right? MAC address, and ARP, right? Now, we already discussed this, right? That, hey, what are the MP reachability NLRI fields, right? What are the fields? MP reachability NLRI, AFI, SAPI, and VTEP, right? And then it will be followed by route type, which we want to send MAC advertisement route, and route length of this, right? So, and after that, it will follow its that type 2 more detail, right? Type 2 more detail, which is nothing but this information. Okay. So now for each of this type 1, 2, 3, this is separate format. So this is common format, right? Which will be on top of all the route update, right? And after that, this is the unique format for each update message, depending on which update you want to send, right? So this is type 2 update message. So first of all, it will be route distinguisher. What is the RD, right? RD value. So if we have to go through this, right? So this is, this is what we already discussed, common format, which will be present on all type 1 to 5, right? Followed by which type of advertisement we are sending, type 2, and length of that, right? This is type 2 and length. Now followed by this, right? First is route distinguisher, correct? So route distinguisher is the RD value what we have configured under that VLAN, right? Under router BGP VLAN, right? So if I have to show you, so yes, this one, right? RD value, what we have configured here. correct? So this is the RD value which we will send. Okay, and this is the RT value which also we'll see where it will be there in update. Okay, so these are the information we are going to send. So this is route distinguisher, RD value, right? Now next is Ethernet segment identifier. Right now it is 0000. Okay, so let's come here on that. Oh, I'm going. Yeah, Ethernet segment identifier, right? Which is 0. So in MLEC case, right? This is related to type 1 and type 4 route for multi-homing. Basically, this is for multi-homing, right? So for MLEG, right? MLEG, this is always 0. Ethernet segment identifier is 0. So this is 0, right? Because right now for this lab setup or the packet capture is for MLEG, right? So it is 0. I'll explain you in type 1 what does this mean, Ethernet segment identifier, right? Then Ethernet tag ID. Ethernet tag ID is also 0, right? For VLAN base bundle. So if you remember, for VLAN base bundle, right? VLAN base, we don't need to send Ethernet tag, right? VLAN base, we don't have to send Ethernet tag because we have RD and RT separate for each VLAN, right? And based on that, we should be able to distinguish this MAC address belongs to which VLAN. RD, RT is sufficient because each VLAN has separate RD and RT. But with VLAN aware bundle, right? Multiple VLANs has same RD and RT, right? And for that, we need other tag like Ethernet tag or VNI to understand this MAC address or routing in whatever information we are sending belongs to which VLAN, right? So in that case, we will have, in case of VLAN base, it will be 0. But in case of VLAN aware bundle, right, this will be non-zero, right? It will have Ethernet tag VLAN value, whatever VLAN 10, 20, that value will be here. Okay. Then MAC address length, right? So length of the MAC address, right? So Ethernet tag is 0, MAC address length is 48 bits, right? And the MAC address. So basically, what information we are sending here? Okay, so here if you see, there are two advertisement, two information we are sending, right? At a time, two information, both are type 2 route, right? So if I have to show you, so this is the MAC advertisement type 2 length, route distinguisher, ESI, Ethernet tag 0, MAC address, and MAC address. The MAC address information, what we are sending, right? So this is the MAC address, which is learned on your VTAP locally. So this is your VTAP 1, which has loopback address 1.1.1.1. And there is one host, right? H1, which has this MAC 2FD1. So as soon as H1 sends some packet here, you learn the MAC address here, locally learn the MAC address, right? In your MAC address table. As soon as you learn this MAC address, you create this EVPN type 2 route, right? With all this information, right? The common header, right? Common header, then type 2 route, right? Route distinguisher, which is you already have configured, right? As 100:100 RD value, right? So you create this RD, Ethernet segment, and Ethernet tag is 0 because it's VLAN based. MAC address is this. This is the MAC address which you have learned, right? And VNI is 100. So you have this 100 VLAN configured with VNI also is 100. So you are sending VNI information, right? So this is the information you are sending to all other VTAPs, right? 222, 333. So once they receive this update, right? This VTAP receives the update 2.2.2 VTAP, right? It will check, hey, this MAC address, right? Let's take it as D1, right? D1 MAC I have received for which VLAN. So you now have RD and RT also, I will show you. So based on that RD and RT, you will find that, hey, this belongs to VLAN 10 or 100, right? VLAN 100, let's consider, right? So VLAN 100 D1 and then behind which VTAP 1.1.1.1, right? So you will update your MAC address table and VXLAN address table based on this type 2 update message. Okay, any question? Any have you understood how this works? How you are sending MAC update message, and based on that, how another VTAP will populate its MAC and MAC address table and VXLAN address table? Any question on this?
So this gets this gets advertised as soon as the MAC is learned, right?
Yes, as soon as your MAC is learned, you will advertise this.
But where do to which neighbors do we advertise this?
Okay, yeah. Okay, so see, okay, so this is like okay, so your topology is like this, right? Leaf spine. If you talk about data center, right? So it's a leaf spine, correct? So these are the leaf, right? And then spine, correct?
Okay. So spine will be route reflector. Got it.
Yes, route reflector or route server, right? Anything. So basically you are advertising this information to all the spines, right? Correct. And then spine will have connection to all the other VTAPs, right? And they will advertise to all other VTAPs. So basically spine is nothing but just forwarding your route. Whatever route it receives, it just forwards it. And it will not change the next hop. So you will have configuration next hop unchanged, right? So basically when you receive this route, right, it's eBGP, right? So as per eBGP, next hop should be this guy, right? Spine IP address. But you will configure next hop unchanged so that this next hop will be retained of this VTAP, which is 1111, right? So now
it should be IBGP, right? Route reflector we configure in.
No. So okay, so there are two variants. See, you can configure IBGP, okay, between leaf and spine. Spine can be route reflector, right? So that is one variant, right? And you create all this as a route reflector client. Okay, so that is one.
Okay.
Another possibility is you can configure EBGP. Okay, you can configure eBGP. In that case, this spine will not be route reflector, right? eBGP, there is no concept of route reflector, right? But that same concept, right? What is the concept of route reflector? Why you have to use route reflector in IBGP? What is the reason?
It's a central point basically to avoid full mesh.
Yes, full mesh, right? Now, if in eBGP, there is no route reflector concept and we don't need it, right? But in eBGP also, to avoid full mesh, see, basically what is my what I want to achieve is this route, right? From this VTAP, I want to advertise it to all the other VTAPs, right? That is my end goal, correct? Now to achieve that, what are the options? I need to have EVPN neighborship with each VTAP individually. If there are 100 VTAPs, this guy should have EVPN neighborship with all the VTAPs, right? 100 eBGP peering, EVPN peering.
Yeah.
That's not scalable, right? So what we are using is, even with basically eBGP, we are using concept of route reflector. We are just using concept of route reflector where our spine will act as a route server. That's why I am saying route server. Now, in case of eBGP, spine will act as a route server, right? So what it does is the act as same. It's just whatever route it receives, it will just forward it to other guy. That's it. It's just forwarder. Spine act as a forwarder. Okay.
But this sorry, one more question.
No, go ahead.
So this EVPN neighborship, right? BGP EVPN. This is my overlay, or
yes.
Okay.
So let me explain that as well now, as we are discussing that, right? So this is VTAP, multiple VTAPs, right? 1, 2, 3, and for simplicity, let's take only one spine. Okay. So leaf, 1, 2, 3, and this is spine. Now there can be multiple spine for back or redundancy, right? But as a simplicity, let's understand this. Okay. Now, actual whatever locally I learn the MAC address, I want to advertise it to L2 and L3, right?
Yeah.
Generally, I need direct EVPN neighborship between L1 to L2, L1 to L3, L4, L5, all the VTAPs, right? But that is not scalable. What I will have is, this is my loopback address 1.1.1.1, right? This is 2.2.2.2. Or I can have another loopback address. So this is VTAP IP address 1.1.1, 2.2.2, and 333. Okay. So this is VTAP IP address loopback. I also can have another loopback for EVPN established, which is here 21, 25, what you see, right? 21 and all that. So that is another loopback 21, or we can take it as, 11, 11, let's say 11, 11, right? So here also it is 12.12.12.12. This is for EVPN neighborship. Okay. 13, 13, right? Here 13, 13, and here 14, 14. Okay. Now you need to establish EVPN neighborship between leaf and spine over loopback. Okay. This is overlay. 13 to 12 and 14 to 12, right?
Okay.
So this is your EVPN neighborship. So by using this EVPN neighborship, what you are doing is, right, whatever MAC you learn the MAC locally, you generate type 2 address like this, right? You generate type 2 address, right, for that MAC and advertise that to spine. Okay. So you receive this EVPN route in spine, right? And next hop will be this, right? 1111. Basically, whatever means, 1111. Whatever VTAP IP, right? And then you advertise this. What spine will do is just it will forward. You can consider as a concept of route server, it acting as a route server or route reflector, right? The concept is route reflector. It reflects the routes. So it will just advertise this route because it also has EVPN neighborship between this to this, right? So it will advertise that route to this guy and this guy, right? That MAC information, EVPN. So basically your purpose is solved. What the route, right, which you wanted to advertise to other VTAPs, leaf devices, that is achieved by using this spine device, right? Route server. It has forwarded your route to all other VTAPs. Is it clear? Any question on this?
No, it's clear.
Clear, right? Okay, now you want, so this is all about overlay, EVPN overlay, right? EVPN overlay. Now, first of all, to establish EVPN neighborship between loopback to loopback, right? What you need to have?
Reachability.
Yeah, 11.11 to 12.12 ping should work, right? So basically on L1, you need to know, you should know how to read 12, right?
Yeah.
And similarly, on another VTAP, when you receive this MAC address, next hop will be 1111, right? Another VTAP. So you need to understand how to reach 1111, right? Correct. So for that, you need to use any routing protocol. You can use OSPF, ISIS, or BGP, right? Correct. But that is normal BGP. So any routing protocol you can use, which is called underlay. That is called underlay routing. This is overlay routing, which is nothing is called is EVPN, right? To advertise type 2 routes, type 3 routes, type 5 routes, MAC, ARP, flood, all that information. That is overlay. Underlay is to establish EVPN neighborship itself. You need to have connectivity between this loopback IP addresses and also VTAP to VTAP connectivity. For that, you need to use any routing protocol. You can use any of this OSPF, ISIS, or BGP. And that neighborship is between L3 interfaces of this. So if you want to use BGP, you have normal BGP between this interface IP and this interface IP. Okay. So you have normal BGP and then you advertise this all loopback addresses by using network command or redistribute connected, whatever way you like, right? So that all this VTAP, and then again that whatever route it has received from leaf 1, spine will advertise to other leaves, right? So basically now everyone knows about how to reach the other VTAPs loopbacks, all the loopbacks. So that is underlay routing, right? To make sure this all the loopback reachability is achieved. Is it clear?
Yes, yes.
Just one question.
Yeah.
So in case we are using BGP in
Mhm.
underlay, so there will be two BGP sessions. One is for underlay and one is for overlay, right?
Yes, there is two BGP session. One is for underlay. Okay, so let me just correct you. You are right, but there are two session, right? One is normal BGP,
Yes.
IPv4 BGP, right?
Correct.
Which is between interface IP addresses,
Point-to-point links. Okay.
point-to-point links.
Correct.
And another will be EVPN BGP, right? MPBGP or EVPN BGP, which will be between loopback to loopback.
Okay. Got it.
Is it clear?
Yeah, sure. Clear.
Yeah. And underlay, for underlay instead of BGP, you can also use OSPF or ISIS, right? That is up to customer. At least in same DC. That's not true OSPF and ISIS if you have MPLS and service provider, right? So that's not true. But otherwise you can use OSPF or ISIS. Goal is, or even static, right? Static route. Goal is to have reachability between these VTAPs, loopbacks, right? And also spines loopback, so that EVPN comes up and VTAP to VTAP reachability is there. Is it clear? Any question? If this is not clear. And also, have you understood concept of route server, right? Why we need this? Because when we come to the configuration, right, you need to understand this. So any question on this?
I'm good. Thanks, Vishal.
Okay. Okay, then I think we are good. So let's move on to this, right? So yeah, we discuss about all this, right? All this, correct? Now there are few more fields, right, in type 2 update message. One is extended community route target, right? Route target. So as we already know, right, we along with RD, we also send RT, route target information, right, in route update, correct? So that's what is this. So these are the path attributes, extended community, right? And if we mark here more, this is the route target, right? 100 export route target. So along with RD, right? Along with RD, right? Which is nothing but 100. We also will advertise route target information, which will be as a part of extended community. Extended community. Okay. In your type 2 update message. Okay. So we are also advertising type route target in type 2 update message. Next is route MAC extended routers, MAC extended community. This is optional, right? We will see when this is needed. Right now for this type, for this one, we don't have this, right? Another one is extended community MAC mobility. Again, this is where I'll in couple of slides next, I'll explain you when this is needed. Right now, it is not here in this packet capture, right? Because it's not always there needed. And next, last is tunnel encapsulation extended community. Basically, you have to mention, so see, data plane can be VXLAN or MPLS, right? What you want to use, that depends. Basically, it can be VXLAN or MPLS, right? So tunnel encapsulation extended and community is nothing but you will mention what encapsulation you are going to use for data traffic, right? So it is VXLAN encapsulation, right? So basically, this is the type 2 route update message format, right? You have route distinguisher, Ethernet segment identifier, we'll discuss more. Ethernet tag is 0 for VLAN base, then MAC address information, and then MPLS label or VNI extended community, route target, and encapsulation method. These two we will discuss in next slides. Okay. And there are IP address field as well, right? So in this, if you see, right, 1 minute. Yeah. If you see here, there is IP address field is 0. So basically this is only MAC update. This one, this is MAC update, right? You are advertising MAC that, hey, I learned this MAC and this is my MAC address. Okay. But if you see the other MAC advertisement route, right? If you see here, this MAC is there and IP address is ARP is also there. Basically IP associated with this MAC, which is nothing but ARP, right? So if you find here, this is ARP update, right? Which has MAC and ARP combination, IP combination. So this is ARP update, right? So basically what we are doing is this VTAP, right? And this is the host H1, which is IP address of this is 100.10, right? 100.10. This is the IP address of this host, right? And MAC is D1 MAC. As soon as this guy sends out app request for the gateway or any packet, right? You update the MAC address locally and also update the ARP address locally, right? You update MAC and ARP locally. As soon as you update the MAC and ARP, you learn locally, you create this two route. One is ARP route, type 2 route, and the one is MAC only route, right? Which we have seen previously. So you create two type 2 routes, right? Both as next hop as VTAP 1. So both are under this next hop, right? Both the routes, and you advertise this to all the other VTAPs. Okay. So other VTAPs will understand, receive this type 2 update message, route message, and then it will learn the MAC address as well as it will also update its ARP table, right? ARP table, right? So yeah, so by using one message, right, we are advertising both information, type 1 and type 2.
Vishal,
Yeah.
I had a quick question.
Yeah.
So when we are so in this NLRI information, right, we have two routes, but it's for like the same MAC address. So like we have one that has the MAC and IP binding.
Correct.
So is it not enough to just send one which has like both MAC and IP binding, and that can be used?
Yes, actually I was going to that. Basically I was going to ask you this questions that, see, this exactly, this is covering both, right? MAC and ARP, both information, right? Why we need to only send MAC as well, right? Correct?
Yeah, that was
unnecessary burden, right? So what do you think? Anyone else has idea why?
So this MAC plain route is derived from the MAC table, right? And MAC plus IP is derived from the ARP table. Maybe in case if there is MAC aging difference, it could cause issues. That's why we need to see if both are present or not.
Right. Yes. So let's say H1, right? H1 is sending packet to any other VTAP. It has sent app request. So it learns the MAC table, MAC address, right? And it also learns the ARP, right?
Yeah.
Do we have both different tables, right? MAC and ARP?
Yeah.
Why? Because as Akshit mentioned, both have different aging table as well, right? Generally, MAC aging timeout is 5 minutes, right? 300 seconds, 500 minutes, 300 seconds. And ARP aging time is how much? 4 hours. Correct?
Yeah.
Default. Another thing, see, you might have seen multiple times, many times, right? When you do show ARP table, right? You see that a 1.1.1.1, but ARP is MAC is not learned. Not learned, right?
Yeah.
When this happened? Because your MAC is flush out in 5 minutes. So you initially learn MAC and ARP, right? until 5 minutes H1 is not sending any packet, so your MAC is flushed out, right? MAC entry is flushed out, but ARP still remains, right?
Yes, yes.
So you see this type of that ARP is not learned, right?
Yeah.
So that's the reason basically both are independent table, right? And let's say this is the case where MAC is flushed, but ARP is still there. And then if you are using only one format, how will you update other guy that, hey, you flush the MAC, but keep ARP?
Got it. Got it.
You got this,
Yeah.
right,
Yeah.
everyone? So yeah, that's the reason, right? We have two different information. One is for specifically MAC and one is specifically for ARP. So in this condition, right, what will happen? ARP. Okay. So initially we advertise both of this route as soon as we learn the MAC and ARP. After 5 minutes MAC flushed out, right? So what we will send is, we'll just send this MAC route update, and that is also unreachability NLRI, right? Where is that? Yeah, MP unreachability NLRI, and we will say that, hey, flush out this MAC from your MAC table. But you still have, we still need to keep ARP. So we'll not send this update. We'll say withdrawn route type update, right? Withdrawn update that remove this MAC, right? Because that MAC is flushed out. Okay. Is it clear?
Yeah, Vishal. Yeah.
Okay. But yeah, good that you brought this point so that, you know, we don't miss out at least discussing that. Okay. So any other question? Okay. So yes, so this is how it happens, right? If we have to check, so server 1 MAC 1, it locally MAC will learn, right? Then data plane learning. Then what VTEP 1 will do is it will advertise type 2 route, which is locally learn MAC address plus IP separately, both the information ARP and MAC information. It will advertise through BGP, and it will also add sequence number, right? So sequence number is nothing but the field which, but that is not always there. Okay, so this field, oh man, yeah, this extended community MAC mobility, in that field that sequence number will be there, but that will not be always present. I'll explain you when it will be present, when it will not. But basically it will send type 2 route, right? And then that route will be received here, and then it will update its MAC and ARP table based on the route received, right? And similarly, whatever local route it has received, learned, it will send the update, this update type 2 route to other VTEPs, and that also will learn this. Okay. So this is again the capture, right? What I have already shown you, right? So EVPN MAC advertisement route, type 2 route, correct? Route distinguisher, RD value, ESI is 0, Ethernet tag is also 0, right? Ethernet ESI is 0 because we have AMLAG, right? Ethernet tag is 0 because it's VLAN base, correct? And then VNI, this is VNI. This is old packet capture where it used to give this random value, right? And then we have to check the basically this we have to check this. So initially, now it is updated, but otherwise it used to give some random value, and then based on this X value, we have to derive a decimal value to find out what exactly it is, which will come as 100, right? Hexadecimal 64. But yeah, that initially the previous version of Wireshark was not detecting this. It was giving any random, basically random value, and that's what is this in this one. But now it gives the correct value of VNI. Okay. So yeah, that is this. Then RD, right? And MPLS label. Yeah. So route distinguisher and route target as well, right? So these are the different fields, right? And this is one more, as we discussed, right? Why we need different type 2 updates for MAC and ARP, right? So this is only MAC update and this is MAC plus IP ARP update. And that's what we discussed, right? That here we have ARP update and this is only MAC update, right? And what is the reason for that? That's what we discussed. All other fields are same, right? Everything RT and VXLAN, everything is same. Just you will update this IP also in ARP, right? So okay, now we'll discuss this ARP suppression and all other stuff, right? MAC mobility in next session. Okay. So any question for today? Any question, doubts you have till now?
This,
Oh, sorry.
go ahead, Victor. It's okay.
Okay, just a quick one. So when we are generating the route for the MAC versus IP, so like let's say for example that host comes up, it doesn't send an ARP request, so but we land the MAC maybe through another
Any packet,
packet.
yeah, any packet. Got it. Yes,
So
yes.
in that case, we will generate the MAC advertisement route and send out, even if we have not landed the app, or
yes, you are right, absolutely right. So see, it all depends on what table you have updated, right? So as you mentioned, H1 sends out any packet to another host H2, which is same VLAN, right? So it does not have to, basically it will send out, or basically it has already resolved R for another host. It just sends out data packet, right? So yeah, in that case, you will update the MAC table, right, of H1. But ARP is not, you have not learned R for H1, right? So in that case, whatever update you have, you will send that type 2 route update immediately as soon as you learn this MAC with only MAC information, not ARP. Now, let's say H1 wants to communicate to any other different VLAN host and sends out ARP request after some time, right? After 10 minutes. And now you learn the ARP also. Immediately you will generate another type 2 route with ARP information, only ARP, right? Because MAC you have already sent. Okay. Yeah. Okay. Any other question?
All good for me.
Okay. Yeah, there was anyone else? Yeah.
So this is like a gateway is on my MLAC pair or the leaf switches, right?
Yes.
Can or do we have scenarios where the gateway is on spine?
Yes, we have different scenarios. So say this is leaf, right? There are different scenarios, right? We have one is you can also use this spine, right, as a gateway, okay, for gateway. So basically now this VTAPs will become L2 VTAPs. This is L2 VTAP. So basically this is the host, right? And host has gateway on spine, and that's why this spine also is called leaf spine, which is combination of leaf and spine, right? VTAP plus spine, correct? Where your gateway is this spine and this is L2 VTAPs. Or you can also have in centralized case, right? In centralized, you can also have all the VTAPs as L2 VTAPs, right? Spine as normal spine. And then there are two VTAPs, which are L3 VTAP, which has all the gateways for routing, VLAN routing. So these are L3 VTAPs, two, one MLAC pair, all other are L2 VTAP. This is centralized, right? Correct. So yeah, we have different, all this basically. So in this case, this is called, when this is spine is your gateway, right? This is called L2 fabric, layer 2 leaf spine architecture, L2 LS. When this is all L2 links, right? L2 VTAPs. When you have this L3 VTAPs, right? All the L3 VTAPs, and this is L3 links, then this is called, that is called layer 3 leaf spine architecture. Okay. So this is two different types or variants of design, right? And which, if you want to study more on this, you can again refer our document, basically our web, Google page, where you should be able to understand all this. So we explain resources. Okay, yeah, design, right? We explain EVPN design. So this is one is custom design. This document is what are different types of designs available, right? So leaf designs. So what was traditional initially, right? Initial we used to, okay, so first year dual home, single home, this compute leaf, border leaf, you might have heard all this. So storage leaf, right? So these are concepts is explained, then completely design leaf spine, and then this is traditional we used to have, right? And then leaf layer 3 leaf spine design and layer 2 leaf spine design, right? So you can refer all this. And then there are complex designs as well, where this generally this VTAP, this is L3 VTAP and this is spine, you have layered L3 link, right? But in case some customer might use L2 links, right? So there are different redesign, right? Complex designs, which is there. So yeah, you can refer this docs to understand more about this. And this is also different guides, L2 LS, L3 LS. This is in depth, right? EVPN deployment guide. So yeah. Any other question?
Hey Vishal, I got a quick one.
Yeah.
If you go to the slide with the ESI, the Ethernet segment, identify the topologies. So I guess you know how we had before, we had two, even earlier than this. It was yeah, we can even take this for example.
1 minute. Which one? This one?
The one where I was showing the different types of ESI, like diagrams.
Okay.
I think it was like closer to the start of this session.
This
one?
one?
Yeah, this one.
Okay. Yeah.
So if I have this sort of like let's just say I have the middle design. If I have like a host that's not active, it's just single homed, it's no longer in this. We're not using EVPN multi-homing. So then that single homed device, it's going to send like let's just say if we just have a device connected to one of the leaves.
Okay, only single home, you mean to say, is it?
Yes.
Like this? Okay.
Yeah. So then when this guy sends the ARP update and it hits the leaf, how does the second one learn about it? Through the type 2 update?
Yeah, that will be okay. So in this case, right, single home or even active standby, right? Even active standby, this is same as a single home, right? At a time it is single home only, right?
Yeah.
So for in both this scenario, you don't need to have type 1 or even MLAG required, right? Because as soon as you learn the ARP, you are going to send type 2 update, which will again advertise to all the VTAPs, right? And they will learn MAC and ARP. So that's not a problem. Okay. Yeah.
Oh, okay. If like another question, I'm not sure if the question's a valid one. If let's just say you have like the second topology where you have two active NVEs.
Yes.
And you have one single home device.
Yeah.
On let's just say on VTAP 1. You
still
have some
home.
active.
Okay. Yeah.
Yeah, you still have like one active device configured. But you also have like a single home device. Now, when you send the ARP to the VTAP, it sends like a type 2 to its PR, right?
Yes.
Can they have the same AS number in BGP? I guess if you have a route reflector, because if you advertise the BGP update, the ARP from one VTAP to the second one, the AS will be the same, right? But if it goes through the route reflector, we still update the ARP or no?
Okay. So, okay, so let's go one by one, right? So first is in both these cases, right? This is host H2 and this is H1, right? As soon as you learn the MAC address and ARP on for both of this, right? MAC and ARP, you are going to generate type 2 route for both of that host MAC and ARP type 2 route and advertise to all the other VTAPs. So that's not going to change. Okay. Only thing will change here is because see, you send the MAC address here to this VTAP, right? But this VTAP also belongs to same host connected, right? And who will tell that hey, this is same, right? It should not happen that this VTAP should send this packet when this VTAP wants to communicate with this host. Instead of sending directly, it should not send the packet to this VTAP, right? So basically that's where type 1 and type 4 comes into place, right? To update this table VTAP that hey, we are sharing common segment here, Ethernet segment here, right? So that's when we'll discuss when we'll talk about more about type 1 and 4 that how this is achieved. Okay. So basically to answer your question right now, both as soon as we learn MAC for this and ARP for this, we will generate type 2 routes for all of them and advertise to all the VTAPs. Okay. So that is one. Okay. Another
that makes
yeah.
Sorry,
Go ahead. You have any question? Yeah, go ahead.
When you know how we said we advertise the ARP to all the other VTAPs, the other VTAPs, can they be in the same
AS number?
like
yes. So yeah, now let's talk about AS number, right? So this is AS number 1 spine. Let's keep it different, and this can be one same, right? All other VTAP. Let's say for leaf we are configuring AS1 and for spine we are configuring AS2, right? We can have this design, but the point is when you advertise this route eBGP, right? This is all eBGP. If we are talking about we are using eBGP. When this route is received here, you will not install this route, right? Because it is same AS number. You are receiving route from AS1, right? Which you have, correct? So as per eBGP, route loop, you will not accept this route. So basically then you have to configure allow AS in, right? So that you consider this route, right? So this is one type of design, okay, where eBGP. Another type of design is you have different AS number for all the leads, 1, 2, 3, 4, 5, and spine also has 6. Same you can keep for spine, so that you don't have to configure allow AS in, right? Now it's at all leaf VTAP has different AS number. So this is another way of design, right? You can also use IBGP, right? So again, now you will have one, all leaf will have 1, 1, 1, 1, right? All spine will have 2, 2, 2, and then you will configure spine as route reflector, right? So this is another way of design as far as BGP is concerned, right? So you can use multiple ways of combination of BGP, right, with AS numbers into this in your network topology. But yeah, you have to make sure if you are whatever way you are using, you have to enable that allow AS in or route reflector based on the way you have implemented it.
Yep. Okay. Yeah, makes sense.
Yeah.
Thank you.
So we have this type of document also. Maybe you can just search on again that same Google page. So where this type of different scenarios, eBGP, IBGP, same AS number, different AS number, that different ways are also there. Yeah.
Thanks.
Okay. Yeah. Any other question? Okay.